will convert time domain signal to frequency domain signal. Fourier transform will convert time domain signal to frequency domain signal. Inverse Fourier transform will convert frequency domain to time domain signal. Frequency domain to time domain signal. Okay. And we know that if x of t is there, we put double-sided arrow and x of j omega. This omega is nothing but frequency domain. T is nothing but time domain. On the top of this double-sided arrow, we write it as Fourier transform pair. Time domain x of t means frequency domain x of j omega. Frequency domain x of j omega means time domain x of t. Okay. So forward direction it is Fourier transform, reverse direction it is inverse Fourier transform. Forward direction it is Fourier transform, reverse direction it is inverse Fourier. Now for the given diagram, let us start writing. Let the name of the signal be x of j omega. Now x of j omega, write an equation. It is having an amplitude 2 units at origin. So I will write 2 times del of omega. Okay, and it is having amplitude right side, it is having 0.5 height, and it is at omega minus omega naught, shifted impulse. Del means impulse. Omega, del of omega means at origin. Del of omega minus omega t naught means at omega naught, shifted impulse, height is 0.5. Again 2 units height present at 3 omega naught, shift is there, 3 omega naught. So omega minus 3 omega naught, we are having a height of 2. This is right side, origin, right side, 2 heights are present. Now I am going to left side. Again 0.5 is present and it is advanced. Shifting left means advance. So it is minus of minus omega, which will be plus omega naught. Again the height is 2 units. 3 omega naught left shift. So omega plus 3 omega naught. This is equation 1, equation for the given diagram. Okay. Now what I will do, I have to apply inverse Fourier transform and find the time domain signal. Time domain signal is represented by x of t. X of j omega frequency domain means time domain is x of t. Okay. Now this constants will not have any time domain or frequency domain. Constant values will not have any time domain or frequency domain. For del of omega, what is the time domain? If you see already in the previous question for del of omega, we have calculated time domain is 1 by 2 pi. Okay. So 2 into 1 by 2 pi is the time domain. This is using the properties. We can do this question. 0.5 is constant. We don't have any time domain, frequency domain for the constant values. Omega minus omega naught. You have to remember these values because these are properties. Omega minus omega naught. It is 1 by 2 pi e power j omega naught t. 1 by 2 pi e power j omega naught t. Okay. Now, the first question on the left, second question on the right. Okay. What is the difference you see? Left side is del of omega. Okay, left side question is del of omega and right side question is del of omega minus omega naught. Frequency domain shifting is taking place. That's why I told you it is a shifting property, frequency shifting property. Frequency domain, one shift is there. Okay, in time domain what you have to do, del of x of t is already there. For that x of t, one exponential to be multiplied. Okay, for the x of t, exponential to be multiplied. Frequency domain, one shifting is there. Time domain, you have to multiply with some exponential. Same thing I am applying here. So frequency domain, it is 1 by 2 pi already there in the first question. Left side question, it is 1 by 2 pi already there. So that 1 by 2 pi is time domain. Along with that, you have to add one multiply. We have to multiply one exponential factor. Okay. And that exponential factor is e power j into how much is the shift. In frequency domain, you can see omega naught is the shift. So time domain, you have to add that exponential factor e power j omega naught t. And that's why the first question and the second question, it is nothing but time shifting property. Hence, you have to remember and proceed with the next problem. Okay. Now, del of omega minus omega naught, del of omega minus omega naught, time domain is 1 by 2 pi and e power j omega naught t. This is the Fourier transform. This is the Fourier transform for given del of omega minus omega naught. Next is a constant, it is 2. Again, you have 3 unit shifting. So 1 by 2 pi will remain same. How much amount shifting? 3 omega naught. So you have to put that as in the power of e. In the power of e. Okay, you have to put that 3 omega naught shift. Plus 0.5 is a constant. The 0.5 as it is I am taking. Now here if you see, there is a shift to omega plus omega naught. Omega plus omega naught. It is opposite. Okay. So if you see shift is minus omega naught means exponential power will be positive. Shift is plus omega naught means power should be negative. Exponential power should be negative. Okay. And that we will apply here. 1 by 2 pi will be retained. E power minus j omega naught t. E power minus j omega naught t. Plus next term it is 2 into 1 by 2 pi and e power minus j 3 omega naught t. This is the inverse Fourier transform for last term in equation 1. Last term in equation 1. This is equation 1. Okay. Now, whatever possible things are there, you can just simplify. Whatever possible is there, you can just simplify. 2 and 2 will get cancelled in the first case. In the first term, 2 and 2 will get cancelled. 1 by pi will be there. In the second case, you can write 1 by 4 pi e power j omega naught t. Similarly, somewhere else, you are also having e power minus j omega naught t. I am putting them together. Then here again 2 and 2 will get cancelled. 1 by pi is there. E power j 3 omega naught t present. Again 2 and 2 in the last term it will get cancelled. 1 by pi e power minus j 3 omega naught t. Okay. This is the next line simplification. This is the next line simplification. If you want, you can combine them wherever possible. If you want, you can combine them. So what can be done? 1 by pi plus 1 by 2 pi. Okay, and remaining things e power j omega naught t plus e power minus j omega naught t divided by 2. In the next line, you can write it as cos omega naught t plus, okay, multiply and divide with 2, multiply and divide with 2. So you will have 2 by pi and then combine these exponentials e power j 3 omega naught t plus e power minus j 3 omega naught t divided by 2. Okay, and finally it is 1 by pi plus 1 by 2 pi cos omega naught t plus the last term is 2 by pi again cos 3 omega naught t. This is the final answer. Time domain signal x of t. Final answer, time domain signal x of t. 3 terms are there. Okay, at the ending 1 by pi, then 1 by 2 pi. Okay, this is the final answer. 3 terms are there. This is the final answer. What I have underlined in red color. This is about time shifting property we are using for finding inverse Fourier transform. Finding inverse Fourier transform.